Good morning, class. Welcome to 5.3A, Graphing Linear Inequalities. Okay, when we graph inequalities, the first thing we want to do is graph the boundary line, which essentially is that equation, that line. So when you think about how do we graph linear, that's how we're going to do it. If it's like the y-intercept, do we have, the slope-intercept? Do we have something we can find our x and y intercepts? But it's going to graph the line. And then when we start looking at that, there's two things we need to consider. Just like when we had the open dots or closed dots, we are looking to either do solid or dashed. So if it is equal to, what we are looking at here is a solid line, because that would mean they are included. If they are not equal to, that is when we're going to do a dashed line, because that would tell everyone that those answers would not be included. So that's the first thing we understand, just kind of like your closed dot, open dot, solid line, dashed line. Then we want to make sure we shade one side of the boundary. It's either going to be above or below the line. And the easiest way to do this, there's two ways, but one way is to just test out your points. So pick a point, any point on the graph. Now we're going to want to try to use 0, 0, if that's possible. And you'll see why. As soon as we plug in 0 for x and 0 for y, that makes our calculations really easy. The only time we couldn't use that would be if the line goes through the point 0, 0. But really we just want to plug it into that inequality, and we got to figure out if it's true, then we shade where that point is. If it's false, we would have to shade the opposite side from where that point is, and we'll take a look at that in a few seconds. The inequality sign, now this is only if it's in slope-intercept form. So if it's like a y equals mx plus b, when you have that less than, we're going to shade under. And if you have that greater than, it's going to be shade above. And that's the same for, of course, your non-equal to's as well. So let's take a look at a few examples here. Okay, let's take a look at example 1. First thing we need to do is start with the line. So if you remember in slope-intercept form, we want to start at the y-intercept, and then the slope is going to tell us rise 2 over 1. So that would mean down 2, back 1, down 2, back 1. Okay, so once we get a couple of these points in there, the next thing we need to determine is dashed line or solid line. Well, if there is no equal sign, this is going to tell us, let's make sure this line is dashed. So this is your boundary line. Now what we're going to want to look at here is then to figure out, do we shade above or below? So if we're going to look at a test point, so again, we're going to test out this point 0, 0. So just to kind of show you what's going on, we are going to test out 0, 0. And what that means is if this is x and this is y, we can plug these into our equation. And the reason we want to use 0, 0 is because, well, what's 2 times 0? So the question is this inequality true? Is 0 less than 3? Well, this is true, so that makes this point true. That would make this side false. If we plugged any number in, say we pick like, negative 4, 4 as our test point, that's going to end up being plugged in and being a false statement. So remember, once we determine that the 0, 0 is the true side, this is the side that should be shaded. And we should have something look like that. Now again, when we have the less than symbol, that is going to be a little shortcut when we look at the y less than 3 to say, all right, less than means we need to be going underneath that line. Okay, so let's take a look at another one. Okay, start with graphing your line. We got y-intercept, down 2 over 3, down 2 over 3. So you can go up to back 3, up to back 3. Now this one does have an equal sign, so we got to determine, like I said, are we doing dashed or solid? So since it does have an equal sign, we are going solid. And then at this point, we're trying to figure out which side to graph. So again, with the test point, I'm going to test out 0, 0. So if we plug in 0, and we know that negative 2/3 times 0 is 0, so the question is 0 greater than a negative 1? Okay, it is greater than negative 1, so that's going to make this true. That's going to make this side true, this side false. And what we want to make sure we do is always shade the true side. Okay, and also when we see that y is greater than, that is going to tell us to go above the line. There is a little cheat sheet with that. So if it is in the slope-intercept form, you can use that as well. Okay, let's take a look at the next example. Okay, same process with 3 and 4 in standard form. But these are going to be ones like, how do we graph? Do we want to solve for y, or do we want to use our x and y intercepts? I usually tend to look for my x and y intercepts. So if I say x is equal to 0, 4y is equal to 12. Now again, we're ignoring the sign for the time being. And if we divide by 4, that means y equals 3. So now we have the point 0, 3, which we could graph right there. And then if we do when y equals 0, that means 3x equals 12. Divide by 3 and x equals 4. So that means we could also get the point 4, 0, which is over here. So if we're going to graph, now we can use these 2 points, which, again, look at your sign. There's no equal sign, so that's going to tell us dashed line. Okay, now the only thing we have to do here off to the side is let's pick out that test point. I'm going to pick, again, the test point as 0, 0. So if we test out 0, 0, well, when you plug in 3x, well, basically 3 times 0 plus 4 times 0, is that greater than 12? So 0 is 12. All right, so this one here is now false. That makes this whole side the false side, which is going to make this true up here. So whenever you see that this statement is false, 0 is not less than 12, that's going to tell you it's false, and that's also going to tell us that we need to go and shade the true side. Okay? Same thing over here, 5x minus 6y. Again, I like using the x equals 0. So that way we can just say, all right, negative 6y is equal to 30. Divided by negative 6. And y equals negative 5. So we got the point 0, negative 5. So we're coming down here. What happens when y equals 0? Well, 5x equals 30. Divided by 5. And x equals 6. So we got the point 6, 0. Which is going to be over here. Okay, so what kind of line are we going to draw? If it has an equal sign, that is a solid line. And then we need to figure out, are we going to go above or below? So again, I'm going to test out, always try to test out 0, 0. So if we are testing 0, 0, what's going to happen? So again, just like kind of like the last one, well, 5 times 0 is 0, 6 times 0 is 0. So the question is 0 less than or equal to 30? Well, yes, that is true. So that makes this side true, which would make this side false. And remember, you always want to shade the true side. Now, could you take a second to re-solve one of these and solve for y and then graph above or below? Yes, you definitely could. But that's going to take, I don't know, just a little bit more work, but you would have the option. If you're interested in that, make sure you ask in class. All right. Next problem. Okay, the last thing we need to remember is our horizontal and vertical lines. So this just comes back to y is less than negative 2. So the way I always look at this, if it's saying y equals negative 2, that is going to tell us where's y. That's going to tell us right down there. Let's change that back to red. So y is going to be negative 2. Now, when you have the y is negative 2, every y is going to equal. So this is going to tell us that this is our horizontal line. So take a look. There is no equal sign. So we are dashing the line. Now again, we're going to try to test where is y less than negative 2 or greater than negative 2, and it's partially common sense. But if we take a point 0, 0, now there is no x, so really the question is 0 less than negative 2? Well, no, that is false. So anything up there is going to be false, which makes this side your true side. And again, where do we know numbers are less than negative 2? Well, that would be low. That would be below. Okay, same thing's going to kind of happen with your x's. Now again, when I think to try to remember this is trying to say x is 1, and that's going to make all x's 1. So when we draw our line, this one here now is equal. We're going solid line. Now this one gets a little tricky just because we usually are saying above or below the line. Well, this would be the left or the right. But again, try to test out a point. Is 0, 0 going to be something we want to have? Well, 0 greater than or equal to 1. No, that is again going to be a false one. So that's going to make this side true. And again, think about, use some common sense. Where are numbers greater than 1? That is going to be anything over here on this side. So that's to take a look at how we can graph our inequalities and making sure that we are just kind of doing those test points, true and false sides. Always want to have the true side, which is ultimately going to tell us we can pick any point over here, a 5, 4. We could do 5, negative 4. Any of those points over there would all be true statements when you plug them into your inequality. All right, there should be some practice online as well as working on some of our worksheet, which we'll do in class. So good luck. Finish up that Canvas assignment for those working from home. Anybody working in class will be working on the worksheet. All right, good luck. Have a nice day.